Hello students, once again I welcome all of you in our third chapter, chemical reactions and equations. Today we discuss oxidation and reduction, types of reaction in which we have addition of oxygen is oxidation, and reduction is also addition of a hydrogen, that is a reduction. And this type of reactions, these two type of reactions we will discuss today. We have given some example in our book. I just write down those things. C plus O2 and another one MgH2. It gives magnesium plus hydrogen and CH3, single bond CH3. It gives CH2. Okay, so this is first equation, second, third, and this is last one, that is fourth. If we observing carefully in these four reactions, what you have to see, we will see that twice Mg plus O2, it gives twice MgO. That means the magnesium is combines with oxygen which is in the air, and we can say that the product is magnesium oxide, that is combination of oxygen with a metal magnesium. Here is carbon is reacted with the oxygen and it can form oxygen. So in both these reactions, what you have to see, the reactants combine with oxygen. The reactants combine with oxygen to form a corresponding product, that is magnesium oxide and carbon dioxide. And this type of reaction is called oxidation reaction. In oxidation reaction, what you have to see, in oxidation reaction, reactants react with oxygen or it combines with oxygen to form a corresponding oxide and a corresponding product. It is called oxidation. And another definition of oxidation is that magnesium hydride is there, magnesium MgH2, magnesium is there, and hydrogen is delivered from magnesium hydride. Hydrogen is delivered, and this type of a reaction is also hydrogen is loses in this reaction. Here is also CH3 single bond CH3, and here is also we can say the CH2 double bond CH2. Here is also hydrogen is loses, and this type of reaction, the reaction in which hydrogen loses or oxygen gains or combines, and this type of reaction is called oxidation reaction. Okay, we have in oxidation reactions we have to see some examples related with it. In this some examples related with it, that in our book we have given some examples, that ethyl alcohol CH3 CH2 OH. It oxidizes in the presence of K2, Cr2, O7 and H2SO4. H2SO4. It gives acetic acid CH3COOH. So in this reaction, here is ethyl alcohol. Ethyl alcohol oxidizes to form acetic acid. So what you have to see, the substance which can provided the oxygen which is necessary for the oxidation is provided by the potassium dichromate. Potassium dichromate provides oxygen to oxidize ethyl alcohol in presence of a acidified liquid, that is H2SO4, in presence of H2SO4. And this type of a reaction in which there is a they have provided a specific a chemical substance which can provide the oxygen for the oxidation, and this is also called oxidation process. Here the substance which can provide oxidation oxygen for an oxidation is called oxidant. It is called oxidant or oxidizing agent. Oxidizing agent. Okay, oxidizing agent. So the substance which can provide oxygen, which can supply oxygen for oxidation which is needed for ethyl alcohol to convert it into acetic acid, and the substance is called, this substance is abbreviated as oxidant or oxidizing agent, that is K2Cr2O7. So in this way, oxidation is the process in which reactants combines with oxygen. Reactants combine with oxygen to form product, and somewhere we can say that there are some substances, the specific in a specific chemical reaction, some specific substances are there which can provide oxygen to carry out oxidation process, and this substance is called oxidant or oxidizing agent. Oxidants or oxidizing agents. They have given this example also. In another example, they have given one equation is that twice KMnO4, okay, plus 10 FeSO4, 10 ferrous sulfate is there, plus 8 H2SO4. It gives rise to potassium sulfate, K2SO4, plus twice MnSO4, twice MnSO4, plus 5 Fe2SO4 thrice, plus 8 H2. Here is the reaction. Potassium permanent is react with FeSO4, and in presence of a sulfuric acid, we can easily find that there is oxidation process is done. In oxidation, what we have to see, ferrous sulfate is converted into a ferric sulfate. Here is ferrous sulfate, here is a ferrous, and that is ferric. So there is oxidation is taking place by in the presence of a H2SO4, and oxidizing agent, which is oxidizing agent is KMnO4. KMnO4, that is potassium permanganate. Potassium permanganate is an oxidizing agent which can oxidize FeSO4, that is ferrous sulfate. It converted this substance into ferric sulfate, and it can be done by in presence of a H2SO4. So how the reaction is carried out? This is oxidizing agent, oxidant, and this oxidizing agent, this is oxidant or oxidizing agent, and this provide oxygen. This provide oxidation for a oxidation process, and how the reaction is carried out, we can easily see in our book that in that reaction, what you have to see, which compound is oxidized by KMnO4, and that is FeSO4. The answer is FeSO4. FeSO4 is oxidized by KMnO4. Okay, and how it is oxidized? They have told us that there is transformer. There is FeSO4. You see, SO4 is transformed into Fe2SO4 thrice. That is ferrous sulfate, and that is ferric sulfate. Ferric sulfate. So here is oxidation process is carried out by addition of oxygen. The necessary oxygen is provided by the oxidizing agent KMnO4. Necessary oxygen is provided by the oxidizing agent KMnO4. How the reaction, the ionic reaction is taking place? We just see how the ionic reaction is taking place. How the ionic, and they have told us that twice FeSO4, it is converted into Fe3. Sorry, Fe2SO4 thrice. Okay, so reaction is such like that: Fe plus 2 plus SO4, that is minus 2, and it can give us Fe plus 2 Fe plus 2 plus thrice SO4 minus 2, that is thrice SO4 minus 2. So in this way the reaction is proceed. Ferrous sulfate is converted, or it is oxidized into ferric sulfate. The reaction is such like that, and the ions are Fe plus 2 ions and SO4 minus 2 ions. It is converted into Fe 2 plus ions and thrice of SO4 minus 2 ions. So the necessary substance which can carry out this reaction is oxidizing agent. The oxidizing agent can carry the main role here to oxidize those ferrous sulfate into ferric sulfate, and that is ferrous sulfate to ferric. FeRRIC, ferric sulfate. Okay, ferrous sulfate to ferric sulfate, that is transformation FeSO4 to Fe2SO4 thrice. And this conversion is, they have been given that Fe2 plus, it converted into Fe3 plus. So it is ferrous to ferric. Ferrous, FeRROUS, ferrous to ferric. So conversion of a ferrous to ferric. What you have to see? We have to see that there is addition of a positive charge on the ferric, that iron. How it can be? How it happens? So the explanation is that, and they have given some explanation regarding it, that when ferric ion is transformed into ferrous sulfate, the positive ions is increased. The positive ions is increased, so that, and this process by unit, and what it happens? Why it happens? It loses one electron. Ferrous loses one electron, so that due to losing of one electron, positive charge increases. That means one electron positivity increases in this ferric ion, and so that the increase of positive charge means losing of one electron. Increase of positive charge in the ferric is conversion of a ferrous to ferric. How it happens? It loses one electron. Ferrous loses one electron, so that its positive charge increased. Negative decrease means positive increase, and this positive increase is Fe3. So in this way, the new definition of oxidation is, they have written that oxidation means losing one or more electron. Losing of electrons is oxidation process, and gaining, and opposite of it, that is a reduction. Gaining of electron is a reduction process. We will see afterwards. So in this way, the oxidation is the process when reactants combine with oxygen to form a product, the corresponding oxide or what it may be, and instead of it, the oxidation in the process means a losing of hydrogen, losing of hydrogen, combining of oxygen, losing of hydrogen, and losing of electron, and also the losing of electron is the definition of oxidation. Oxidation is such a process where we can gains oxygen or combines oxygen and lose hydrogen and also lose electron, and this type of reaction is called oxidation reaction. So we are taking the reduction. Reduction is the process. So here we can see that reduction is the process in which reactants react with hydrogen. Reactants react with hydrogen, and this reaction is called a reduction reaction. And also another reaction is that, another definition is that the losing of oxygen is also called a reduction. Losing of oxygen is also called a reduction reaction, and gaining of electron is also called a reduction process. Gaining of oxygen is also called a reduction process. So here we have given example, copper oxide is there. In this reaction, Cu plus H2O. Cu plus H2O. Here copper oxide is there. They have given that copper oxide, black copper oxide is there, and hydrogen gas goes out. Hydrogen gas is passed over this copper oxide. What will happen? The reaction is such that the copper and water is produced there. So in this way, what you have to see here is a reduction. Here is a reduction of oxygen. Okay, here is a reduction and oxidation of hydrogen. So oxygen is removed from copper oxide, and what happens then? H2 is produced, and due to the removal of oxygen, reduction process is happen, and the reducing agent is H2. And addition of oxygen. Oxidation is also process. This process is also happen there, so that oxidation and reduction, both these process happen there, so that it is called as redox. Reduction and oxidation. Reduction of a copper oxide is there, and oxidation of H2 with O. Reduction of a copper oxide is there. The reducing agent is H2. Okay, so in this way we can see that the reduction and oxidation, both this reaction happen simultaneously, and that's why it is abbreviated as a redox reaction. Both these reactions happen simultaneously, so it is called a redox reaction. In this way, oxidation and reduction process are happen simultaneously, so that when positive charge on atom or ion is increases or negative charge decreases, it is called a oxidation. Positive charge increases or negative charge decreases, it is called a process of oxidation. And when positive charge decreases and negative charge increases, and this type of reaction is called a reduction reaction. So we have already seen what is meant by oxidation and what is meant by reduction, and the combination of both these reactions happen simultaneously. Then we can easily say that the reaction involved in this reaction we can see the oxidation as well as the reduction, and this reaction is, in shortly, we can abbreviate it as a redox reaction. So I can stop here, and today we discuss oxidation and reduction. In the next in the next lesson we can see corrosion and acidity, and these are the last topics we will study in our next lesson. Okay.